Okay, my pretties. Find arc measure. Starting off with several definitions that we need to know. They're important and you need to know what I'm referencing to. So run through these real quick. Central angle. A central angle of a circle is an angle whose vertex is at the center of a circle. In this instance, this is a central angle. Vertex is at the center of the circle. Alright, a central angle. Kind of named it because it's at the center of a circle. A minor arc is a part of a circle measuring less than 180. So a minor arc is anything less than half of the circle. A major arc is a part of a circle measuring between 180 and 360. So if it's bigger than 180, if the arc is bigger than 180, it's called a major arc. So in the blue here, that's called a major arc. And notice how a major arc is labeled. A major arc always has 3 letters. A, D, B is the major arc. The minor arc is always 2 letters. A, B. So that's a way you can tell, and that's how we should label or name our major arcs. Is major is 3 letters, minor is 2 letters. And you notice they got the little arc symbol. That's not a segment. That's like an arc. Like it actually curves. Semicircle is an arc with endpoints that are at the endpoints of the diameter, so half a circle. Measure of a minor arc. The measure of a minor arc is the measure of its central angle. Okay. So the minor arc and the central angle is exactly the same. So if this angle is 13, this arc is 13 degrees. All right. Congruent circles. Oh, excuse me. The measure of a major arc is the difference between 360 and the measure of the related minor arc. So it's basically saying if you want to know the major arc, and this one is 20, then you take 20 from 360, so that means the rest of it is 340. That's simply all that's left. Congruent circles, 2 circles are congruent circles if they have the same radius. All you need in order to be congruent circles is have the same radius. That's important. Congruent arcs, 2 arcs are congruent if they have the same measure and they are arcs of the same circle or of congruent circles. All right, so it got to be congruent circle or the same circle for them to be congruent. All right, so here's a key concept. This is something I've already talked about, but the measure of a minor arc is the same as the measure of its central angle, and vice versa. If you know one, you know the other. If you want to find the measure of the major arc that goes with that particular minor arc, you simply take that number, in this case 50, and subtract it from 360, and that'll tell you what the major arc is. So ADB is 310 and AB is 50. They should add up to be 360. Now here's a couple examples of that. Name the arc, well, this is just naming anyway. Name the arc shown in bold. Okay, this would be, and you would write this down, this would be arc AB. So the little arc symbol, arc, and then you would do A, and I'm using my mouse so I stink. AB. Now, that's the bold part. The bold part here is the major arc. So that gets arc A, D, B. And it's the mouse, so I'm really slow with it. But that's the major arc that's shown in bold. That's the minor arc shown in bold. All right, so that's just naming the arcs. Now find the indicated arc measure. So I'm looking for a degree, a number. Whenever you see measure in any math, they're talking about a number. All right. So this one is kind of small. And let's see if I can make it get any bigger. Oh, it's kind of weird. All right. Anyway, they want to know what the arc AB is. Remember I said it's the same as the central angle. So arc AB has to be 90 degrees, right? Because that's a right angle. If this is 90 degrees, then the arc is going to be the same as that. Arc ACB. So saying ACB. Now think about that for a second. Is that a major arc or a minor arc? That's a major arc because it has 3 letters. So it's ACB. If the whole thing is 360 and this part is 90, what does that leave ACB? Well, you do 360 minus 90 and you should get 270. All right. Now they want to know what arc CA is. Arc CA. Now, arc CA, if you notice, I got the little congruent symbol. This angle is congruent to this angle, which is congruent to that angle. So notice it's the whole circle that's congruent. So what would be the measure of each one of these if all these angles are the same? Well, the whole thing is 360, right? Correct? What it is the measure 360 divided by 3, because this is split up into 3 equal parts. So that would be 120 for this, 120 for this angle, and 120 for this. How did I get 120? 360 divided by 3. Why did I do 360 divided by 3? Because I noticed that each one of these 3 angles are the same, which means if they're all congruent, they have to be 120, 120, 120, because those are the only 3 same numbers that add up to be 360. So what does that have to do with CA? If this angle right here is 120 degrees, arc CA is also 120 degrees. All right. Find the measure of each arc where DF is the diameter. Okay, so they give you problems like this, and you got to pay attention to the diameter and stuff because they're helping you out. But they want to know the measure of each arc. All right. So, let's do this. Arc ED. I don't have the arc symbol, so arc ED would equal what? Hopefully you notice that it'll be 117. Arc ED would be 117. Now, based on that, what would arc EF equal? Arc EF, remember this is a semicircle right here, so I'll do 117 minus 180, which I don't know off the top of my head, or actually 180 minus 117, and I'll get 63 degrees, and both of these are degrees, by the way. So this one is 63, this one is 117. What about arc EF? Excuse me. FD. Well, that would equal 180 degrees, right? FD either way would be 180 degrees. Could you tell me what arc DFE would be? Do you know what arc DFE would be? It would be 180 plus 63. 180 plus 63 will give you, I believe, 243 degrees. Why? Because, well, I'm kind of getting ahead of myself. And you'll see arc addition postulate. The measure of an arc formed by 2 adjacent arcs is the sum of the measures of the 2 arcs. So basically, if you got arcs right next to each other, you can add them together and you can get the measure of both of them. So for example, we can look at arc AC. Arc AC is from here to here. So I would do 29 plus 108, and that would be 137, I believe. Because the central angle and the arcs are the same. So what about arc ACD? ACD. So you got to follow in that same order. ACD would be 29, 108, 83. In fact, you should try to find every single one of these and maybe pause it right now, and I'll put up the answers here in a second. Okay, here's the answers to that particular part of the arc addition postulate. Alright guys, this is another thing that we need to know, and it's called arc length. This is a formula that you need to know. The arc length is different than the degrees. An arc length, if I had a circle, the degrees is going to be the same. Whatever this angle is going to be the same as that arc in degrees. But that doesn't mean that the distance, the actual length of it, is going to be the same. In fact, they're not going to be the same in many cases. And so the way you work this formula is, if you want to know the arc length, M, or the number on top, is the arc or the central angle in degrees. All right? So whichever arc you're talking about, you take that arc in degrees and you put that number there, but you have to know the radius. That's what R is. And so we have this example here. If I want to find the arc, that's an arc, C, not an R, arc length, they give us this stuff. All we do is substitute in to the formula where I put 25 over 360 2 pi times 6. You can simplify that to be 25 over 360 times 12 pi. All right? So, there's a couple of ways you can work that. I'm going to say first, in my calculator, 25 over 360. That reduces to 5 over 72. Okay? So that's the same thing as 5 72 times 12 pi, which equals 60 pi over 72. Just multiplying straight across. That's what you do with fractions. And so if I did 60, you can use pi on your calculator. I use the pi button right there. 60 over 72, let's see what I get. I get 5 pi over 6. And so my arc length is simply 5 pi over 6. Now, of course, if I wanted a decimal, all I would have to do is hit the button on top of enter, and that's approximately 2.6. So arc length, again, is just a formula. I wanted to show you this. It'll come up from time to time, or maybe not. But I wanted to show you what the arc length is and how to figure it out. All this is, guys, is just simplifying. You could have simplified this all the way up here. I just kind of took it step by step. All right? Any questions? No, let me. Ha 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 ha.